Okay, get ready to have your minds blown because today we're going to take a deep dive into something truly wild.
Uh-oh.
Spacesuit technology, but with a twist you won't believe. Diapers.
Diapers.
Yep, you heard that right, diapers.
Wow, that's not what I was expecting.
I know, right? You're probably thinking, how could diapers possibly be relevant to, the high-tech world of space exploration?
Yeah, I gotta admit, I am a little curious.
Well, we're going to uncover the secrets behind a super intriguing new material
Okay.
that's caught the attention of the European Space Agency.
The ESA?
The ESA, yep. And it could revolutionize astronaut safety.
I'm all ears.
So we're talking about a potential game changer for radiation protection,
Oh, okay.
which is one of the biggest challenges astronauts face out there in space.
Right. Radiation's like no joke, right?
No, it's not. See, out in space, they're constantly bombarded by solar radiation
And don't forget about deep
Yeah.
space cosmic rays.
these space cosmic rays, which are incredibly dangerous.
Yeah, those are nasty. They're like tiny little super fast bullets whizzing around out there.
Yeah, and unlike here on Earth, where we have, the atmosphere and the magnetic field to kind of shield us, astronauts are much more vulnerable.
Yeah, we take that for granted for sure.
Yeah, they can actually get a year's worth of radiation exposure in a single day.
A whole year.
In just one day. It's crazy.
That's a scary thought.
It is scary, and that's why finding effective ways to protect astronauts is crucial, especially, with ambitious missions to Mars and beyond on the horizon.
Yeah, you got to think long term, right? If we're serious about like sending people to Mars, we need to up our game when it comes to radiation protection.
Absolutely.
So I'm still trying to wrap my head around this. How do diapers fit into all of this?
Well, the secret weapon is something called superabsorbent polymers.
Super what?
Superabsorbent polymers, or SAPs.
SAPs, okay.
And yes, these are the very same materials found in everyday diapers.
So are you telling me astronauts are going to be wearing giant space diapers?
Not exactly, but you're closer than you think.
Okay.
These SAPs are incredible. They can absorb hundreds of times their weight in liquid and transform into a gel-like substance.
Oh, like a gel.
Yeah, it's called a hydrogel.
Hydrogel, okay.
And this hydrogel is actually the key to creating a new type of radiation shielding.
Interesting. So what makes this hydrogel a better solution than what's currently being used?
Well, the current methods rely on water, which is good at blocking radiation, but
Yeah.
it's bulky and prone to leaks, which, in the vacuum of space...
You definitely don't want a leaky spacesuit.
Not at all. That's where the hydrogel comes in. Provides a more even distribution of protection, much less likely to leak even if it's punctured.
So it's kind of like a built-in safety net, right? Like if something happens, they've got a bit more time to get back to safety.
Exactly. And what's even cooler is this hydrogel technology isn't limited to just spacesuits.
Really?
It's got potential to be used for shielding habitats and even storing water in space.
Wow, that's impressive. So we're talking like a multi-purpose space material here.
Exactly, but we'll delve deeper into those applications in the next part of our deep dive.
I'm definitely intrigued. This is a lot more to this than I thought.
Right. Who knew that something as, mundane as a diaper could hold the key to unlocking a whole new era of space exploration?
You got that right. So let's go back to the spacesuit for a minute. How do they actually get this hydrogel into a spacesuit?
Now, that's where the magic of 3D printing comes in, but before we get into that, let's take a step back and talk about the challenges of designing a spacesuit that can actually, withstand the rigors of space travel.
Okay, yeah, that makes sense. I mean, it's not like you can just, slap some duct tape on it and call it a day, right?
Right. Designing a spacesuit is no easy feat.
No, it's got to do a whole lot more than just look cool.
Exactly.
I mean, it's got to protect astronauts from extreme temperatures, right, micrometeoroids, and, of course, radiation, all while allowing them to move and work effectively.
It's like designing a personal spacecraft.
Yeah, exactly.
Every element has to work in perfect harmony to keep the astronauts safe and functioning.
And, as we push further into space, those demands only become more challenging.
Oh, yeah.
Longer missions, deeper space exploration, and the ambition to, establish a human presence on other planets, requires spacesuits that are even more resilient, adaptive, and comfortable.
Yeah, it's mind-boggling to think about all the factors that go into designing these suits. But getting back to the hydrogel, how does 3D printing play a role in incorporating it into spacesuits?
Well, 3D printing allows us to create custom-shaped hydrogels
Oh, okay.
that fit perfectly into the contours of a spacesuit. Imagine being able to print a layer of this protective hydrogel directly onto the fabric of the suit.
So no more bulky, rigid layers of traditional shielding?
Exactly. With 3D printing, we can create a spacesuit that's not only safer, but also lighter and more flexible, allowing astronauts to move more freely and perform tasks with greater dexterity.
It's like upgrading from a clunky suit of armor to a sleek, high-tech suit that enhances their abilities.
That's a great analogy, and here's where it gets even more interesting. This hydrogel technology isn't just about improving spacesuits. it has far-reaching implications for the future of space exploration as a whole.
Okay, I'm hooked. What else can these hydrogels do?
Remember how we talked about the hydrogel's incredible ability to absorb and retain water?
Yeah, hundreds of times its own weight, right? It's like a super sponge.
Precisely. Now imagine using this hydrogel to create radiation shielding for entire habitats on the Moon or Mars. Think of building structures with walls that are infused with this protective gel.
Wow, a radiation-proof house. That would be essential for any long-term habitation plans.
Absolutely. It would allow astronauts to live and work in these environments for extended periods without worrying about constant exposure to harmful radiation.
That's a game changer, and I bet the water storage potential is just as impressive, especially considering how difficult and expensive it is to transport water to space.
You're absolutely right. Launching anything into space is incredibly costly and water is heavy. But imagine being able to send these hydrogels in a dry, compact state and then rehydrate them once you reach your destination.
So it's like packing a dehydrated space oasis.
In a sense, yes, it would dramatically reduce the payload weight and make it far more efficient to transport and store the large amounts of water needed for long-duration missions.
This hydrogel technology is starting to sound like a Swiss Army knife for space exploration, tackling so many challenges at once.
It truly is a versatile material with enormous potential, and the research is still ongoing.
Oh, cool.
Scientists are exploring new formulations, testing durability, and figuring out how to scale production to meet the demands of future missions.
It's exciting to think about what they might discover next, but are there any potential downsides to this hydrogel technology?
That's a great question, and it's important to consider all angles. One challenge is ensuring the long-term stability of these hydrogels in the harsh conditions of space. They need to withstand temperature extremes, radiation bombardment, and the vacuum environment without degrading or losing their effectiveness.
So there's still a lot of testing and fine-tuning to be done.
Absolutely. Another area of focus is scalability. We need to figure out how to produce these hydrogels on a much larger scale to meet the needs of future missions, whether it's for spacesuits, habitats, or water storage. We'll need significant quantities of this material.
It's a classic case of going from a brilliant idea in the lab to figuring out how to make it work in the real world, or in this case, the off-world.
Precisely. But researchers are optimistic. They're exploring different production techniques, looking at new materials, and collaborating internationally to accelerate the development of this promising technology.
It's a reminder that space exploration is a global endeavor requiring the brightest minds from all over the world to come together to solve complex challenges.
Collaboration is key, and this brings us to another important aspect of space exploration, which is the ethical dimension. As we venture further into the cosmos and consider the possibility of establishing a human presence on other planets, we need to ask ourselves some tough questions.
Like what sorts of questions? What are some of the ethical considerations that come into play?
Well, for instance, if we do find a way to make Mars habitable, who gets to decide who goes? How do we ensure a fair and equitable distribution of resources? What impact will we have on the Martian environment, even if it's seemingly barren? These are complex questions that go beyond the realm of science and technology.
They touch on issues of human rights, environmental responsibility, and our place in the universe. It's a lot to grapple with.
It is, but it's essential that we have these conversations now as we're developing these incredible technologies that could potentially make such scenarios a reality. We need to make sure that our exploration of space is guided by a strong ethical compass.
So as we move forward, it's not just about innovating and pushing technological boundaries, but also about ensuring that we do so in a way that's responsible, equitable, and mindful of the bigger picture.
Exactly. It's about combining scientific progress with ethical considerations to create a future where space exploration benefits all of humanity.
It's amazing how far we've come in this exploration of space technology, and starting with something as, unexpected as diapers.
Yeah, it really goes to show, the power of innovation and how we can find solutions to really tough challenges in the most surprising places.
It's incredible to think that something, we usually associate with everyday life could be instrumental in pushing the boundaries of space exploration.
Definitely. It's a reminder to stay curious, keep an open mind to new ideas, even if they sound a little bit out there at first.
Absolutely. So as we wrap up this deep dive into, DIPE-inspired tech, let's recap what we've learned.
Okay, sounds good.
We started by talking about the dangers of radiation in space, right? And how the traditional methods for shielding, well, they have their limitations.
Yeah, the current systems are bulky and they can leak.
Right, and leaks in space, not a good thing.
Definitely not ideal, especially if you're in a suit.
And that's where these superabsorbent polymers, or SAPs, come into play.
SAPs, right? These incredible materials we find in diapers.
Yeah, exactly. They can absorb hundreds times their weight in liquid, turning into that gel-like substance called a hydrogel.
Hydrogel. which, as we've discussed, is a total game changer for space exploration.
Oh, yeah, for sure. It's lightweight, flexible, and it provides like really reliable and even protection against radiation,
And it's much less likely to leak even if it gets punctured.
which gives the astronauts more time to get back to safety.
Exactly.
It's like a
Right.
built-in safety net in their spacesuits.
Right?
And beyond spacesuits, we also talked about how these hydrogels, could be used for shielding habitats and even storing water.
Yeah, this hydrogel is a real multitasker, solving so many challenges with this one, ingenious solution.
And remember, we also talked about the ethical considerations, right, as we venture further into space and think about, possibly establishing a human presence on other planets.
Yeah, those are important conversations to have, for sure.
So it's not just about, innovating and pushing those technological boundaries, but also about making sure we do it responsibly, equitably, and with the bigger picture in mind.
Absolutely. So what do you think? What does the future hold for this groundbreaking tech?
Well, it's hard to say for certain, but the potential, is just enormous.
I agree. Like lighter, more flexible spacesuits could let astronauts explore with more freedom, be more agile.
And maybe radiation-shielded habitats could even pave the way for longer and safer missions, even permanent settlements beyond Earth.
It really is an exciting time to be following all the developments in space exploration.
It is.
Who knows what incredible discoveries and advancements are waiting for us just, out there on the horizon.
And the biggest takeaway for me today is that sometimes the most unexpected innovations come from the most ordinary places.
Yeah.
Perhaps there are other everyday materials right there in front of us, just waiting to be harnessed for, the next giant leap in space exploration.
That's the beauty of science, right? The possibilities are truly endless if we just stay curious and keep pushing those boundaries.
So to you, our listener, we leave you with this thought. What seemingly mundane things in your life might hold the key to unlocking the mysteries of the universe.
Keep exploring, keep questioning, and who knows, you might stumble upon the next big discovery.
Thanks for joining us for the deep dive.
See you next time.